Hello everyone, welcome to today's session. My name is Franz. In our last session, we were dealing with organic chemistry, and I've introduced you to what is organic chemistry, and then I also spoke about the homologous series, the 9 different types of homologous series, and also shown you the different types, or rather the functional groups of each and every one of the 9 different types of homologous series. And I promised you that I'm going to tell you on how to move from that particular part of the 9 different types of homologous series until we get to where we will end our session today. So now let's continue. So let's just make, or rather do a recap. Let's say homologous series. I made an analogy that said homologous series, I made an example is the Soto people. Homologous series is like Soto, and then we have the 9 different, or rather the different categories of Basotho, and then what you can see, if you see a cat, you know that is Basia. Basia falls under Basotho. So I said we have 9 different types of homologous series: 1, 2, 3, 4, 5, 6, 7, 8, and 9. So I'm going to use a red color to write the different types of them. The first one being alkane, alkene, alkyne, haloalkane. I'll use this word, or rather the haloalkane only today, and not use the alkyl halides. And then aldehydes, ketone, ester, alcohol, and carboxylic acid. So all of them, they have the functional group in which when you see this particular structure, you know if you see something of this nature, it represents alkane. And I said for alkane, it is single bonds between carbon atoms and being surrounded only by hydrogen. And I said alkene is, you will see the double bond between carbon atoms, and also it has to be surrounded by hydrogens only. Alkyne, it is triple bond. When you see triple bond between carbon atoms and then being surrounded by hydrogens only, then that is an alkyne. So there is one thing that I also want us to see. Since there is a link between these three, they are called the hydrocarbons. Hydrocarbons meaning that they are substances that consist only of hydrogen and carbons only. So meaning hydrogen is amalgamation of two words. Hydrocarbons, amalgamation of two words, hydrogen and carbons. So meaning when you see alkane, alkene, and alkyne, you'll always see two elements basically, which is a hydrogen and a carbon. The only difference that is going to be there is that the first one, alkane, has single bond, second one, alkene, has double bond, third one, alkyne, has triple bond. So all of these three, they form part of what you call the hydrocarbons. And then we proceed to number 4, which is haloalkane. Here we have to introduce, we see there is something called, we see an alkane here. So meaning we have a halogen combined with alkanes. So meaning instead of having an alkane being inclusive of only 2 elements, which is carbon and hydrogen, here is going to be carbon, hydrogen, and alkane. So it only, carbon, hydrogen, and halogen. So meaning it is still going to have single bonds between carbon atoms, and then it is going to be surrounded by hydrogens and halogens. And then we come to aldehyde. Aldehyde, I just want to make a scenario here. We have its functional group. It's something like that. It has a carbon bonded with a double bond to oxygen, but it is on the first carbon. The functional group of aldehyde, it is always on carbon number 1. And then it's synonymous, it goes hand in hand with ketone. whereby its functional group is in between two other carbons. You see, so aldehyde and ketone are what we call, I'm going to explain them later on in this particular lessons. They are called what we call isomers, functional isomers. I'm going to write it as Fi. So as time goes by, I'm going to show you what does Fi mean. Functional isomers. So both of them. Similarly, with ester and carboxylic acid. If you remember in my previous video, I ended up with alcohol because I wanted to show you the link between these two homologous series, whereby an ester, its functional group is in between two other carbons, but the carboxylic acid has its functional group at the end, or rather on the first carbon, similarly to aldehyde. So this is what we've done in the previous video. This is the highlight of the previous video. So let's proceed to what I want us to deal with today. What I want us to deal with today is what we call nomenclature. Nomenclature meaning naming of organic molecules or compounds. Nomenclature or naming of organic, let me just say compounds or molecules. Underline. Yes. So meaning we will be giving you, the examiner is going to give you structures in different forms. You'll be given structures, We have two types of structures. We have what we call structure number one, structural formula. Structural formula. Meaning this one is an explicit structure. An example of a structural formula is to be something like this. So meaning here you explicitly see the bonds between the elements, and then you see, and it's explicit, it's there, it's like a skeleton. It is like a skeleton of the molecule. So you see the different types of structure, bonds. Here you see single bond between carbon atoms, which tells you it forms part, or rather it is an alkane. And then it is surrounded. Why am I saying it's an alkane? Because it is surrounded only by hydrogens. So this is how you draw the structural formula. So another type of structure is what you call condensed. I'll use SF for structural formula. Condensed structural formula, meaning if I were to write the condensed structural formula of this molecule here, is going to be CH3, meaning how do you write a condensed structural formula? There is one carbon. How many hydrogens are there on that one carbon? 1, 2, 3. Hence I wrote CH3. And then you have carbon number 2, you write C. And then how many hydrogens are there? You write H2. There's carbon number 3. You see there's C and 3 hydrogens. You're going to write CH3. So these are the types of structures that are going to be given to you. And then you'll be asked what is the name of this particular structure. And then I'm going to another one which is called molecular formula. It's not a structure, but is a formula that can be given to you, and you'll be asked to give us the name of the molecule. So molecular formula will be, let me call it number 3, C3, sorry about that. C3H6 plus 2, 8. H8. So sometimes you will be given this and asked to draw this and then give a name, or maybe you'll be given directly that and being asked what is the name of that molecule. So normally I like to say, to make your life easy, draw this thing and from this molecular formula, write or rather draw the structural formula in order for you to be able to see and then what are the different bonds between the carbon atoms, or how many elements are included in that particular thing. And then from there, your life is going to be easy to an extent that you will be able to give the name of this particular molecule. And I also promised you last session that I'm going to give you what we call the general formulae of some of these particular homologous series. Since I want us to do the nomenclature or naming of organic compounds of 3 or actually 4 of them, which is alkane, alkene, alkyne, and haloalkane. Now I'm going to give you the general formula of the first 4. Formulae. Alkane. It has CnH2n plus 2, and then alkene is CnH2n, and then number 3, alkyne is CnH2n minus 2. So in other words, here when you have 4 carbons, you will be saying C4, and then you're going to put the very same number here, which is going to be 2 multiplied by 4, which is going to give you 8. 8 plus 2 means is going to be 10. Let's make a practical example with this one. We have 3 carbons here. So it's going to be like this. Going to be C3H2 into 3 plus 2, which is going to be C3H6 plus 2, basically C3H8, which is exactly that which we did there, but we did not use the general formula to find that. We only counted here. So it's easy to count if you have a smaller number of carbons, but if you have big number of carbon, large number of carbons, like example, if you are given C8, you see, you would not go around trying to count how many hydrogens are included in that. So we'll just say C8 and then H2 into 8 plus 2. So you have a calculator with yourself. So you'll say 2 multiplied by 8 is 16. 16 plus 2 is 18. So you'll basically know that a carbon that has a structure that has 8 carbons has 8 hydrogens surrounding it, if it is an alkane. So the same is true also with the following, the fourth, any of these things. I forgot to show you the one for haloalkane. It is CnH2n plus 1x, whereby x stands for the halogens, basically. Yes. So now, if we have the general formulae and then understand the structural formula, condensed structural formula, and molecular formula, let's try to get into business. The examiner will not say to you, give us the name of this molecule, or rather write the naming or nomenclature of this molecule. The examiner is going to ask you, what is the IUPAC name of a molecule? Meaning, when you see that this is an abbreviation, when you see IUPAC name, just know, fella, they want you to give us the name of a compound that is being presented to you, or rather before you, that has been placed before you. So you know what to do basically. After I've shown you here, you'll be able to understand what is it that the examiner expects of you. So let's consider a few things before we get to name this molecule. Let me call the first one the stem. And then I'm going to write 10 of them. And let me call this one A. 1, 2, 3, 4, 5, 6, 7, 8. And then here I'm going to put a line. I'll explain why. And I have 9 and then 10. So here I'm going to have meth, eth, prop, but, pent, hex, hept, oct, non, dec. So these numbers are supposed to be this way. What does this mean? These numbers and the number goes hand in hand with what I've written here. This simply means that a carbon chain that has one carbon is called meth. So it starts with the name meth. And then if it has 2 carbons, eth or eth, 3 carbons, prop, 4 carbons, but, 5 carbons, pent, 6 carbons, hex, 7 carbons, hept, 8 carbons, oct. Let's go to the example that I've just made. So I had this thing as my example. This is the structure that I gave you a few moments ago. So let's check. Before we come to name that, there's also what we call suffix. Or maybe suffixes maybe I should write them here. Write the 9 different types of homologous series: alkane, alkene, alkyne, haloalkane, aldehyde, ketone, ester, alcohol, carboxylic acid. So what I'm going to do is this. Even though I wrote the homologous series in here, I'm going to write each and every suffix of each and every one here. I'm going to use red for suffixes. So for alkane, the suffix is ane. For alkene, the suffix is in. For alkyne, the suffix is yne, meaning ein, like the ein. Haloalkane is ane, like alkane. And then aldehyde is al. Ketone is 1-one. Ester is like 08 or like weight. 08. So we pronounce it like weight. And then alcohol is ol. Carboxylic acid is oic. Now say that maybe you forgot these things. They are basically there. Alkane is there, the last 3 letters. Even this one, the last 3 letters. Alkane, that. And then aldehyde is the first 2. Ketone is that one. This one, obviously, it does not have it on the structure. And then alcohol is that. Carboxylic also, it does not have its a suffix on its original name. So basically, when you name a molecule, you have to start with the stem. Some people call it a prefix, stem or prefix, and then you have the suffix. So let's try to name this molecule. How many carbons does it have? We count 1, 2, and 3. And then what do? We go to this stem part, and then we say, oh, 3. It has to start with prop, right? And then what is the functional group of this molecule? Oh, it has single bonds between carbons. Cool. Does it have anything else besides hydrogen? No, it has hydrogens outside. They are surrounded by hydrogens. Oh, it fits perfectly into the category of becoming an alkane. Therefore, what is its suffix? Ane. So, what is the full name, or rather the IUPAC name of this molecule? We are going to say is propane. This is how we basically give the naming of organic molecule, or the IUPAC name. We start first checking the stem, and then before the stem and before these two, you check your structure, how many carbons are there, and then the carbons are going to direct you to the stem. And then after being directed to the stem, you will be able to come to the suffix, because you will be knowing the functional group of that particular molecule. I hope this is easy as it seems. Now, let me make an example with something else also, just to try to accommodate alkene. Can you erase this much? Let's check alkene. Let's say we have now. Let's try to find some few things, or rather the name of this molecule. I'm going to, let me draw another structure of alkene. I just want to emphasize some important aspects, because it is very much important to be able to understand them now as we start. Cool. Now we have two structures. I'll call this one A. I'll call this one B. Let's try to name both of them. So let's check the number of carbons there. We see we have 1, 2, 3, and 4 carbons. We have now number of carbons 4. But what is it? What is the functional group of this molecule? Oh, we have double bond. Oh, double bond. Beautiful. Now we need to number here. Say that I have 1, 2, 3, and 4 to show that we have 4 carbons. And then we see that we have a double bond. So the double bond, where is it positioned? So it is in between carbon number 2 and carbon number 3. So we need to note the following. 1, give the position of the, let me not say double bond, let me say the functional group. Functional group, the lowest possible value, or rather number. Lowest number, not possible, sorry, the lowest number. So we will see there, that is point number 1. I'm going to come with point number 2 when you come to this molecule. Here, the functional group, which is the double bond, is between carbon number 2 and carbon number 3. It tells us that the position of the functional group is going to be taken by the number which is less between 2 and 3, which is now at our advantage 2. So the functional group is going to be 2. Now, let's name this molecule. We have the position of the functional group, we have the number of carbons given there, and then we realize that since well it's a double bond, it is surrounded only by hydrogens, therefore it is an alkene. We are going to check the number of carbons now. We see we have 4. So that simply means the molecule have to start with but. You see? So you write your but. Now, this is where it gets interesting. You write the position of the functional group between the stem and the suffix. You see, you write the position of the functional group. Let me write it as a note also. You write the position of the functional group between the stem and suffix. Cool. So now, how are we going to do this? What is the position? We said we're going to choose between 2 and 3. We check the lowest one, which basically now is going to be 2. And then what is the suffix? Now, we checked it is a double bond, so meaning it has an ending of in. So we'll say in. So now, how can you, let's analyze this name. Say that you are asked to analyze this name. Okay, you check the functional group there, that the suffix tells you, oh, this is an alkene. How many carbons does it have? 4. And then where can we find the double bond carbon number 2? You see, alkene, 4 carbons, carbon number 2. Easy peasy. I hope it makes sense. Now, let's attempt structure number 2. Structure number 2, naming it is like this. We are going to count also. I'm going to count in both ways. Starting to count from this side. 1, 2, 3, and 4. And then I'm going to count from this side also. 1, 2, 3, and 4. Now, we realize also that it has 4 carbons, which is beautiful. And then since it has 4 carbons, we need to check, does it, what functional group does it have? It has a double bond. So we know 4 carbons and then in. So meaning it starts with but. Now, why did I start counting number of carbons from both left to right? What is it that I want to show you? I want to show you point number 1. Give the position of the functional group the lowest number. So if I start counting my carbons from the right, I will have position of 1, 2, 3, and 4, meaning the functional group will be between carbon number 3 and carbon number 4. But if I start counting from my left, I'll be having number 1, 2, 3, and 4, which makes me to say the functional group has a position given to it as between 1 and 2. So meaning instead of taking the one from the right, I'm going to take the one from the left because it will give my functional group the lowest number, which is between 1 and 2, and I'm going to take 1. Let me repeat, maybe I was a bit fast. Now, as I counted from 1, from the right, I said 1, 2, 3, and 4. Now when I count from my left, it's the same 1, 2, 3, and 4. However, when I check the position of the functional group, when I start counting from the right, I see it is between carbon number 2 and carbon number 3. So meaning I'm going to have to take carbon number 3, or rather position 3, as my position of the functional group. Nonetheless, when I start checking now from counting from the left hand side, my functional group is between carbon 1 and 2. So between 3 and 1, which one is less? I see it is 1. So the position of the functional group in this case is going to be 1. Hence, I'm going to take 1 as my position of the functional group. Now, we apply point number 2. Where write the position of the functional group between the stem and the suffix. What is my position now? 1. And then what is the suffix? In. You see? So, nonetheless, it is only when the position of the functional group is given to you that you can write it like this. The examiner will know that, oh, when he wrote or she wrote butene, the functional group, or rather the carbon, the position of the double bond is in carbon number 1. But if you maybe you do not trust that, you can continue with your but 1 in. Then that is that. The same is true also with the alkyne. Everything that I've explained here happens also in alkyne. I'm going to change some few things there on the structure just to show you. You have to put double bond, triple bond. Let me erase these positions. We'll start from scratch. 1, 2, 3, 4. Now let's start again by naming that molecule. Let's start with A. Number of carbons, let me outside. Number of carbons are 4. We know we are on bute. And then now we see a triple bond. Oh, we realize, oh, it's a triple bond. So we need to come to "-ine" as our suffix. Okay, you see? So now let's count. We'll start counting 1, 2, 3, and 4. One can, okay, let me count also here 1, 2, 3, and 4. And say 1, 2, 3, and 4. Let me show you the difference here. Why am I not counting twice here? If I were to count, I start here 1, 2, 3, 4. The functional group is between carbon number 2 and number 3. Even if I were to count from this one, 1, 2, 3, and 4. The functional group, even when I start from the right, will be between carbon number 2 and carbon number 3. Hence, I'm not doing it twice. I'm doing it only once in whichever direction that you find yourself comfortable with. So the example, or rather the idea behind this is that if the functional group is maybe the divider and the number of carbons on your left and the number of carbons on your right are equal, so you do not have to count twice. You just know that the functional group is between two numbers that are in the middle. Now let's check the name there. We'll start with bute since it has 4 carbons, and then the position of it is between carbon number 2 and carbon number 3. So we are taking carbon number 2 because it's the smallest, or rather the lowest number, so which is going to be 2, and then the functional group, the suffix is going to be what? YNE. So what is the name of this molecule? Butene, or rather sorry, butene. See, so meaning this is 4 carbons and then it's an alkyne. Position 2, that's where we find the functional group. I hope it is clear. Now let's check again molecule B. Molecule B tells us this thing. It has 4 carbons, and then since it has 4 carbons, if we count from the left to right, the functional group will be between carbon number 1 and 2. But if you come from right to left, the functional group will be between carbon 3 and 4. And I said again, we check the value, or rather the position that is lowest between the first one and the second one. And then we see that 1 is lesser than 3. So we are going to take position 1, which is going to be but1-ine. So that's how you name the first 3. This is just the basics. I'm going to delve deeper into this elements when I add stuff like sorry about that, branches and all of these many beautiful and interesting stuff. So I just want us to start from level 1 and then we'll grow with this particular thing as time goes by. Nonetheless, this is basically how you firstly name the first 3 homologous series. Now let's go to the 4th one, which is haloalkane. Haloalkane, I said to you, it comprises of halogens. So I'm going to draw a structure maybe of 5 carbons, 1, 2, 3, 4, and 5. Okay, 5. So before naming haloalkanes, we need to be aware of few rules. Number 1, alphabetical order takes precedence. Alphabetical order of, I'll call them halogens maybe. Halogens takes precedence. And then number 2, how can I put, let's say the position numbers ought to be taken into account. What does this mean? It means that I'll show you, I'm going to give you two names of this molecule, and then we will check the positions of them, and then we'll decide from there. So now let's try to name. We check what is the functional group. We see two halogens. Halogen number 1 is bromine, halogen number 2 is chlorine, which are here, bromine and chlorine. All right, so that simply means it's what? A halogen, a haloalkane. And if it is a haloalkane, its suffix is ane. Now, how many carbons are there? 1, 2, 3, 4, 5. I have 5 carbons, meaning the prefix or the stem is pent. Cool. Now I'm going to write two names. Let me start counting from this side. 1, 2, 3, 4, and 5. And then I'm going to start counting also from this side. 1, 2, 3, 4, and 5. Now, let's start naming, or rather, let's name from the left-hand side. I want to show you something, or rather, let me not do that. Let's check bullet point number 1. Alphabetical order of halogens takes precedence. What does that mean? You check between the halogens that we have, if there are two halogens. You have bromine and then chlorine. B comes before C. That simply means when we name this thing, our bromine is going to be also named before we write the name of chlorine. So say that we start from left to right. We will be saying 5, meaning also this time, the position of the functional group, I need to name it here. Position of the functional group is not between the stem and suffix. It is outside. It is outside, meaning it's the one that starts the name. It acts as if it's a prefix in a way. So now, as I said, we start from left to right, meaning we're going to see, okay, where is our first functional group in carbon number 4? You are going to tell us in carbon number 4 we have a bromo. Remember, I told you when we started here that we're not going to call them bromine. We will call them bromo. We have 4 bromo, meaning position 4 we have a bromine, which is a bromo, and then also position 2 we have chloro, 2 chloro, and then we now write the name, which is pentane. I'll just squeeze it here, pentane. You see, that's how basically we give the name, or rather we write